So we see the symbol sometimes H, it's enthalpy. Enthalpy is the energy of a system. We can think of the energy as being energy that a system could potentially release. So gasoline can potentially release a lot of energy, and it releases it in the form of heat. Quite often, you're seeing this. You don't see that so often. We'll see the change of enthalpy. And the change of enthalpy is going to be how much heat was given off during some reaction. So how much enthalpy a system loses or how much enthalpy a system gains. For example, if you're burning gas, you're releasing heat. It's a negative change of enthalpy. It's this exothermic heat is exiting your system. So it's exiting the gasoline. So here we see endothermic is when the heat goes into a system. So if you feel something that feels cold, the reason it feels cold is because the heat is leaving your hand and going into the system. For example, these instant ice packs, where you get them at room temp and you break them open and two solutions mix, all of a sudden they get really cold. They get cold because they have an endothermic reaction occurring. And so since the chemicals are actually absorbing enthalpy, they get it from you. So they feel cold because they're gathering enthalpy from the surroundings, and you are the surrounding while you're holding that system. And the heat goes from your hand into the cold pack. Exothermic is when heat exits the system, and that you can think of as a fire. So when you're combusting something, you're rearranging the molecules, and in that rearrangement, heat is being given off, and you can feel that it's hot because the heat is coming to you. So the system is losing heat, and you being the surroundings, you can feel the heat. So the heat is exiting the system and going to you. So here's a couple of energy diagrams that show an endothermic and an exothermic reaction. You can see you have your reactants. You put in some energy to break the bonds apart. And then as they become more stable, they convert this potential energy into enthalpy, so into heat. So you put in heat to break the bonds apart, and you get heat out when the new bonds form. And since the products are more stable than the reactants here, you have a change of heat, which is going to be your change of enthalpy, how much heat was lost by the system. So this would feel hot. Meanwhile, here you have to put in all this heat to break the bonds apart, and you get this much back. So the change of enthalpy for this reaction is how much you put in versus how much you got back. And you can see that you put in a lot more than you get back, so that's why it's going to feel cold. We can use reactions to measure how much enthalpy we're giving out per gram of a reaction. So we can do stoichiometry with enthalpy. So it's the same concept as if you burn twice as much wood, you're going to release twice as much heat. So same thing for a chemical reaction. If I do this reaction once, I'm going to release 393 kilojoules per mole. I know I'm releasing it because, well, for one thing, it's combustion, and combustion tends to give off heat. The other thing is I've got a negative change of enthalpy. So that means the system is losing this much heat. If I were to combust 2 moles of methane, I would give off twice as much heat. So here's an example. I'm going to combust 5 grams of methane, and I want to see how many kilojoules of heat are given off during that time. So I start with my 5 grams of methane, CH4, and I know I'm going to have to put grams on the bottom, grams of CH4. I'm converting it to moles, and I know that if I have 1 mole of methane, I'm going to have 16.0426 grams of methane. And then I know I have to put moles of methane on the bottom. And I can say for every 1 mole of methane, I release this much heat. So for every 1 mole of CH4, I have a change of enthalpy that's negative 393.5 kilojoules that the system is losing. So I go ahead and multiply 5 divided by the 16 times 393.5, and it tells me that 120 kilojoules are given off. So that's stoichiometry. And last we're going to look at